All right. So whenever we talk about a simple monohybrid cross, okay, and this is, we're going to start with baby steps, okay? A monohybrid cross just means that we're only dealing with one gene only, okay? So one gene trait only, okay? So these are going to be the more simplistic forms. We're actually eventually going to get into dihybrid, which means that we have two interacting traits, okay? But otherwise, this is how we're going to start this off with, okay? So if we're talking about seed shape, and this is also one of the things that Mendel actually did, okay? Seed shape can show up as big R for round, so that means that's the dominant trait, and then little r is going to stand for wrinkled, okay? Now, the other thing too that I caution about is that whenever you're reading a question and you're listing off those alleles, okay, always choose the same letter, okay? So typically the R will just stand for like the round trait and then little r. Don't do like a little W or something like that, because then it gets a little bit more confusing once we start showing other inheritance patterns, okay? So keep it simple, keep the same letter, okay? So for our P1 generation, okay, so we're going to only look at the parents. So we're going to take a big R. So what kind of a plant would this show up as? What look does it have? What's the phenotype of this parent? A round pea plant, okay, times a little r, okay? So that's a wrinkled little pea plant. Wrinkly. Those are the ones that go into like the frozen bags. Just kidding. Okay, so the gametes. Okay, this is going to start getting easier and easier. You guys won't have to worry about this, but the only gametes that can be produced are big R, okay? And then for this one, this is little r and little r. Okay, so those are the only gametes that can get produced from those particular plants because they're purebreds, okay, or homozygous plants. So for this first generation, now I'm actually going to show you guys a shortened way to actually do this, okay? So rather than having to do big R, little r, okay, and it's kind of obvious what's going to happen here because it's similar to the last one that we did, okay, you can actually kind of shorten this, okay? If ever you see repeated gametes, okay, this guy right here, or girl, can only ever have big R gametes, okay? So instead of writing out all of this because it's a repeated gamete, all you might actually have to do is just show R, because it's going to have like a 100% probability of that happening, okay? And I'll do both Punnett squares just to show you that nothing's really going to change. Now the same thing with this this wrinkled plant. This wrinkled plant can only produce little r gametes. So instead of just doubling it up, we can just kind of jump to that step there, okay? And kind of get rid of the repeated gametes, because the repeated gametes all have an equal proportion of being picked, okay? So what's going to happen in our original Punnett square, the long way, okay, is the fact that we're going to reproduce all of these and make these diploid zygotes, okay? But if you were just to take that one shot of that, is there a difference in your outcome? No, okay? So let's practice our genotypes again. So genotype ratio, you would say all big R, little r, okay? Is there a difference between how we can express that? No, okay? Or you can say 4 big R, little r, but it means the same because everybody's going to be a big R, little r. And then our phenotypic ratio, is there a difference there either? Big R, little r is going to express as what type of a pea plant seed shape? All round, okay? So the same thing, there's no difference on how those phenotypes are actually going to show up, okay? So because everybody's going to make that little baby. All right, so we're going to jump to the next one, and we're going to show you another, so we're going to cross the F1 generation. So an F1 cross would be big R, little r times big R, little r. So these are the hybrids crossing, or these are the heterozygotes crossing, okay? So making our Punnett square. Now, here's the difference. You cannot do the shortcut on this one because the gametes that are going to get produced between each of these seed plants are going to be different. So you do actually have to list off the different ones when they do show up. So you would still have to do the big R, little r, gametes because you have to represent all of them. Okay? So, first one, big R, big R. Second one, big R, little r. This one right here, big R, little r, and then little r, little r. Okay? So, our genotype ratio. What are you going to put? So, just expressing the genes. How many big R's do we have? Just one. How many big R, little r's do we have? 2 big R, little r's. Okay? How many little r's? 1. Okay? So, that's how you would express your genotype ratio. What about our phenotype ratio? Anything really different than the last one? Who's going to be round? How many are going to be round in that proportion? 3 are going to be round, and then 1 is going to be wrinkled. Okay? So 3 round to 1 wrinkled. Okay? So here are some of the follow-up kind of questions. What is the chance of having a wrinkled, or what's the probability of having a wrinkled pea plant? Okay, so you have 4 possibilities here, 4 babies, okay? So 1 out of 4 total would be a wrinkled pea plant. Okay, so that's the chance. So it's a 25% chance you're going to get a wrinkled pea plant. Okay, what's the chance of having a round pea plant? 75% or 3 out of 4. Okay, so that's what these phenotype ratios are useful for, is actually figuring out that probability. Okay, so you guys are going to get more and more practice on that anyways. Okay, but basically those are the chances of getting that. Okay, so that's part of that probability. Now the other thing too that you guys want to remember is that no matter how many times this will reproduce, it doesn't eliminate those options every single time. So even if we reproduce this a second time, the chances are still going to remain the same. So the second time that these guys reproduce, what are the chances of having a round pea plant? It's still going to be 3 out of 4. So every single time, you don't eliminate an option. You always have the same statistic or probability of having that particular trait being chosen. Okay? And that's also going to end up happening in the sense that, like, how is it that parents can have, like, boy, 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 but then, like, never a girl kind of thing. So you always have a 50-50 chance of having a boy or a girl, but every single time that you have a baby, it's still always going to be just 50% chance, right? Okay? So that's where probability is going to come into play here.